Earlier, you saw how we could use an aggregate function to calculate a total, or some other summary value, for a numeric data field. Aggregating data is usually the first kind of analysis you perform in order to summarize the data and get a feel for it as a whole. One of the first things you might want to ascertain is how many records are in the data set. This is known as the count. Now you can calculate the count for any kind of column, not just numeric columns. It just tells you how many rows there are. For categorical data, you might want to calculate something called the distinct count, which counts how many distinct values there are. In this case, the data set includes sales data for 7 discrete days of the week. The total, or sum, is a common aggregation of interest. For example, Rosie could calculate a total for each numeric field in this 2-week period. Now, some of these totals are potentially useful. For example, Rosie can see that the total revenue, the total number of lemonades sold, the total number of flyers distributed, and how many centimeters of rain fell during the period. But some of the totals aren't so useful. The total temperature is meaningless, as is the total price. The average is calculated as the sum of the field values divided by the number of records. And with a few caveats that we'll explore later, it gives us a good idea of a typical value for the field within the dataset as a whole. The minimum is the lowest value in the dataset for a given field. For example, Rosie can see that the lowest daily income from lemonade sales was $3. Conversely, the maximum is the highest value for a given field in the dataset. The most money Rosie made in a single day was $9. Now, there are many more kinds of aggregation that you can calculate, but these are some of the most common ones.